Hi there. So this problem is asking us to evaluate this integral. Now you have this rational function here. In your numerator, it's of degree 3. In your denominator, it's of degree 1. So typically when you look at a problem like this, your first inclination is to use substitution to evaluate this. And while that's a good idea, that's not going to work, okay? And here's the reason why, is because your numerator up here is of degree 3. So typically what you would want to do is have this be your u and take the derivative of that. And if I just look at my first term, 2x cubed, what I end up getting is I'm going to, is if I take the derivative of this, like let's say I did a u substitution, then du dx is equal to, 6x squared. Okay, and so the problem is that, if this is my derivative, I don't have something squared here. I have a degree 1, all right? And so this isn't going to work. And so I don't want to go forth with this. So we have to think of what else can we do to, simplify this function so that we can integrate it, okay? And the answer to that is to use long division. And so from here, if I set up long division here, like the only way for me to simplify this is by using long division. And so let's do that. So 2x times what is going to give us 2x cubed, and that's going to give me x squared. All right, I'm going to take x squared and multiply it by my divisor. So x squared times 2x is 2x cubed. X squared times 3 is positive 3x squared. All right, subtract your quantity here. So I've got 2x cubed minus 2x cubed. That's going to cancel out. Now here I've got 7x squared minus 3x squared, which gives us 4x squared. And then we're going to bring down our positive 2x. All right, and we're going to repeat that same process. So 2x times what gives us 4x squared? That's going to give us a positive 2x. 2x times 2x gives us 4x squared. 2x times 3 gives us a positive 6x. Let's subtract the quantity here. And so from here, the 4x squareds are going to cancel out. 2x minus 6x is going to give us negative 4x. Let's drop down our 9. And we've got one more step here. So now 2x times what gives us negative 4x, and that's just going to give us negative 2. All right, so negative 2 times 2x plus 3 is negative 4x and then minus 6. So when you subtract the quantity here, all right, then you get 4x, negative 4x plus 4x cancels out. 9 minus negative 6, 9 plus 6 gives us positive 15. Now this is our remainder. And we're going to need the remainder to write our quotient. All right, so our answer here, the quotient, once we divide these two, polynomials here, then we're going to get x squared plus 2x minus 2 plus 15 over 2x plus 3. Okay, and so this is just the simplified version of this. Okay, now this is something that we can calculate, that we can integrate. So from here, all right, let's write our integral now of x squared plus 2x minus 2 plus 15 over 2x plus 3 dx. Okay, now one of the things that we want to do when we're integrating this is to treat each of these as separate integrals and then add them together. All right, that's going to make it a little bit cleaner. I don't normally do that, but I think that that's a really good idea in this case. So here, if I write it as the integral of x squared dx plus the integral of 2x dx minus the integral of 2 dx, and then plus the integral of 15 over 2x plus 3 dx. Now the reason why I'm doing this, the reason why I'm splitting it up, and I could just separate it into two integrals, to do this portion and then this portion, it doesn't really matter, is because I'm going to have to use U-substitution here, okay? And so that's kind of an important part of this, is to make sure we get this part right. All these other parts are really easy, but let's go ahead and do these first three parts at least, just because at this point, those are pretty easy to do. So as a result, we get this. We're going to get x cubed over 3 plus x squared minus 2x, okay? And remember that every time you integrate, you should be able to take the derivative and go back to where you started, okay? And then I'm going to add in the plus the integral of 15 over 2x plus 3 dx. All right, I can still do that, like from here. We'll add in the plus c later. And what I want to do here to help me integrate this is, let's do this. Let's let u equal 2x plus 3. All right, so, my integral here would be 15 over u and then dx. All right, so here's what we've got. Let's do this. So let's find du dx. So du dx over here is going to just give us 2. So then du is equal to 2 dx. And so what I then want to do is really just come over here and just get dx by itself. The 15 doesn't really matter, but let's do this. Let's do that 1/2 du is equal to dx. All right, so let's just get rid of this dx here and replace 1/2 du with dx. So this integral over here is then going to become 1/2 times 15 over u du. Okay, and so from there, what we can do is kind of simplify this a little bit and move our 15 over, and I'm going to do 15 halves. Move that out front and have this be 1 over u du. So now at this point, we can take the antiderivative of this part, and we can get 15 halves times the natural log of the absolute value of u, and then we'll add on that plus c at the very, very end. And we can resubstitute our value of u back into this. And so our final end result of calculating the antiderivative here is going to be x cubed over 3 plus x squared minus 2x plus 15 halves times the natural log of the absolute value of 2x plus 3, and then all of that plus c. And that is your final result from doing this. All right, so hopefully that makes sense on what I did there. Please feel free to reach out to me if it does not, and we'll talk to you soon. Thanks. Bye.